Day pre-algebra. Oops, hold on. I gotta put them back in the. There we go. We are gonna finish going over PO7 today. We talked yesterday. We started talking about integers and ordering them. What was the recommended method for ordering integers? What did we do on the page? What work did we show? Where you didn't have to show this work. If you needed to, what was kind of the go-to here? Yeah, number line, right? And you plot both of them. Whichever number's on the left is the lesser one. Whatever number's on the right is the greater one. Okay, we went through that one pretty quickly. So we'll go over some answers here for what you need to do for homework. If you have any questions, we'll cover those, and then we'll go on to decimals. So I forget which ones we did together, so let's do all of them. -7 is, everybody? Greater than -10, right? It is further to the right on the number line than -10 is, therefore it is the greater value. -4 is less than +2. -2 is greater than -9. -14 is less than -12. Okay, and those are the symbols that you should have in there for each of them. 19 is less than 22. 8 is greater than -8. There was a question about whether those two things would be equal because they do the same absolute value. They are the same distance from 0. However, a positive will always be greater than a negative, right? -16 is less than -13, and -65 is less than -53. Job well done, okay? Ordering the integers from least to greatest, -8 is the smallest, then it comes -6, then -3, then 0, then 5, and then 7. Second one, your order should be -10, -8, -3, -1, +10. And then the last one, let's see, -15, and then -12, -8, -5, -4. Should be your orders there. Any questions on integers? Notice how these are all positive or negative non-decimal numbers, right? Going back to what an integer is. These are all examples of integers. Okay, positive, negative, non-decimals, non-fractions. Okay, decimals. Let's go over some answers for that one. Again, I forget which ones we did together, but here we go. 0.223 is less than 0.793. 67.4 greater than 63.22. 2.54 equal to 2.5400. And 0.27 less than 0.3. I remember talking about this one, and we introduced the stacking, or reviewed the stacking method. If you put that 0.3 out the same number of places as 0.27, you very clearly see 30 is greater than 27. You don't want to compare 27 to 3, right? Because that 3 represents 3/10, which is greater than the 2/10 that the other decimal has. 1.34, less than 1.5. Same kind of thing here. You're not comparing 34 and 5. You're really comparing 34 and 50, right? 34 hundredths versus 50 hundredths. You add that 0 on the 0.5 there. 2.361, less than 2.365. 3.01, greater than 3.001. We can use the stacking method for this one too. Put that top one out to 3 places. And now you're kind of comparing, 10 to 1. 10 hundredths to 1,000. Or actually 10 thousandths to 1,000th. And that is going to be greater. And then 10.999 equal to 10.9990. So the stacking method was kind of the preferred recommended method that we talked about yesterday. Looking at these from least to greatest, again, we'll just stack them all up here. 0.884, 0.89, 0.879, and 0.0884. Our longest decimal is out to 4 places, right? That 0.0884. So we're going to put all these other decimals out to 4 places as well. So now when we kind of compare those, it's a little bit easier to see, which one's the smallest here.
0.89.
Not the smallest.
0.84.
Not the smallest. Not the smallest. 0.0884, right? It's the only one without 8 tenths. It has no tenths. If you put them all out to 4 decimal places, this is like 884 compared to 8,790, compared to 8,900, compared to 8,840. This is the smallest of those 4. Okay? So I think it was Jillian, or maybe it was Bennett, yesterday talked about just comparing the tenths. They all have the same number of holes, 0, but then 8 tenths, 8 tenths, 8 tenths, no tenths. That's got to be the first one. That's got to be the smallest. If you stack them up, you can kind of see that too there. Okay, 884, 8,790, and so forth. So this one's going to be the smallest. Okay, oh, that's wrong. Whoopsie-doo. This one's going to be the smallest. Which one comes next? We can compare 8,840, 8,900, 8,790. Which one would come next? Yeah. 8,790. Then? Gigi? Yep, 0.884, 8,840 is less than 8,900, or 8 hundredths is less than 9 hundredths, right? You can use that also, and so that's the proper order for them to be in. Okay? Are there questions? Feel like there are questions. It took us a while to get to this one being the smallest. So if you didn't get it before and you still don't get it now, let's talk about it. No? I promise you this one's going to be on the homework check tomorrow. So should get that right. Next one, 25.75, etc., etc. Which one clearly is the smallest value here? Gigi. 20.999, right? 25 holes, 25 holes, 20 holes, 25 holes. This one's got to be first. Okay? So then, comparing the other ones, we really only have to stack 3 of them. 25.75, 25.711, and 25.3344. Again, out to 4 decimal places. So let's add a 0 onto that one. Let's add 2 zeros onto that one. And now we're just they all have the same number of holes, right? So now let's just compare these numbers here. 7,500, 7,110, 3,344. Which one's the smallest? Liv.
3,300.
The 3,344. This one here. That's your second one. Okay? Then 7,110. There's your third one, and your greatest one is right here. Okay? Same thing with the next one. If we just add a 0 onto that, we've got 1.20, 1.21, 1.23, 1.25. Here's your least, then next, and next. Okay. And lastly, 7 holes. This is like 7.000, however many zeros we have to add on there. There's nothing more than that. It's exactly 7. All of these also have 7 holes, but then a little bit more. Okay, so this one's going to be the smallest, right? Let's stack the others. 7.39, 7.295, 7.99, 7.4. You got to add some zeros, right? Put them all out to 3 places. 0 there, 0 there, 2 zeros there. Which one comes next? 7's the smallest. We already have that one labeled. Which one comes next, Aiden?
7.295.
There it is. Good. Yeah. 390, 295, 990, 400. That 295 is coming next. And then what? Schlafer.
7.39.
390. There it is. And then what? Zeke. 7.4. And then finally 7.99. Okay. Questions on the stacking method? It's a nifty one.
I don't really get it.
What's your question?
Sorry.
you zoned out. Well, it's a good thing that we record. You can always go back later on. Okay, but basically, Harrison, what's going on here is we're writing out each of the decimals and then adding a 0, so they're all up to the same number of places. And then we can kind of just think about, compare these numbers, 390, 295, 990, 400, and that's why I put the 295 as the next smallest one, because it's lesser than all those other decimals. Okay, that's the gist of it. Putting them all out to the same number of places helps with that visualizing. You aren't comparing 34 with 5, you're comparing 34 with 50. And that's why the 1.34 is less. Okay? I'll try and be more interesting for you. All right. Anything else? Okay. Next one, fractions. And this is the one I'm going to require work to be shown. Someone brought up that you can just use your calculator. And if you divide 3 by 6, 3 divided by 6 equals 0.5. 5 divided by 10 equals 0.5 as well. You can tell that they're equal. Okay? But I want us to start working on developing more number sense, not just what does the calculator say. So yesterday, we talked about why these in fact are equal using number sense. What do? Who can strat that? It's my new phrase.
Well, first of all, 3 on 6 is half and 5 on 10 is half.
Brilliant! Yeah. If we simplify these, they both simplify down to be 1/2, which are equal, right? And so that's why we came up with that one. What do we do for the 3/8 and 7/12? What do we do for the 3/8 and 7/12? Jillian.
Times 3 3/8 equals 9 3/4, and then times 2 is 7/12.
Yeah, so one method, because we did a couple of them here, is we went with common denominators, multiplied both 3 and 8 by 3 to get 9/24, and then we doubled 7 and 12 to get 14/24. And when your denominators are the same, it's super easy to see which fraction is greater because you see, well, what do I have more, right? Fractions are part of a whole. I've got 9 out of 24 versus 14 out of 24. Which test score would you rather have? Okay? Well, probably neither, but given the two, 14 out of 24 is going to be the greater test value. Therefore, 3/8 is less than 7/12. That was one way. What was another strat? James.
I also just look how far the fraction is away from 1.
Yeah. Say more.
If it's 3/8, it's pretty far away, or it's pretty far from half. It's less than the half.
Yes.
So if it's 7/12, 6 is the half of 12, and 7 is more than 6.
Are you sure you didn't watch the video yesterday? That's exactly what we talked about. That's perfect. Yeah. If you look at where these fractions are compared to half, okay, 4/8 would be equal to 1/2, right? We've got less than that. 6/12 would be equal to 1/2. We have more than that. So we know this is less than 1/2. We don't know exactly how much less, but it's less. We know this one, 7/12, is more than 1/2. Again, we don't know how much more. It's just more. But something that's less than 1/2 has to be less than something greater than 1/2. Okay? Great job. Aiden.
I can do the next one.
Sure. How would you strat that?
I did, you could just keep the 14 33rds, and then you can do 5 and over 5/11s times 3. Then you get 15 over 33.
Yeah. Good. 5/11s and 14 33rds. We can see that they are both a little bit less than half, right? Half of 11 is 5.5. 5 is a little bit less than that. Half of 33 is 16.5. 14 is a little bit less than that. So the half trick isn't going to really be helpful here. However, recognizing that 11 goes into 33 evenly makes this multiplication just a one-stop shop, right? Multiply both by 3, 15 33rds compared to 14 33rds. What symbol goes between them? Greater than. Okay? Greater than, right? How about the next one there? What's a strategy you could use for that one? 9/5 and 7/3. Is that a hand up, Jillian? Go ahead.
times, 7 times 5 is 35, and 3 times 5 is 15, and 5 times 3 is 15.
Yep, common denominators works great. We get 27/15. Jillian said multiply each of these by 5 to get that 15. And we have 35/15. What symbol goes in between them? Less than symbol, okay? What's another strategy that you could use here? Yeah.
I also did how many times can 3 go into 7, and that's twice, and then 1/3. And then I did how many times can 5 go into 9, which is 1 and 3, 8, 4, 5.
Great. Yeah, since these are both improper fractions, we know they're both greater than 1 whole, right? So Bennett's saying, well, I know that 3 goes into 7 at least twice, so it's greater than 2. I know that 5 only goes into 9 evenly once, not quite 2 times. Okay? So if this is greater than 2, and that's less than 2, we know that has to be less than the other one. Okay? Converting to mixed numbers is another great option here. 2 1/3, 1 4/5, right? We can see it there too. The nice part about fractions, yes, they're the most difficult because they're just fractions, but you've got a lot of different strategies that you could use. Okay, so when you do your homework and you've got the next 16 minutes to work on it, so number game tomorrow, okay, let's do it. You need to show your work on how you get these answers. If you want to use a calculator to check your answer, that's okay, but you can't use a calculator to find the answer. I've got to see, are you using common denominators? Are you comparing? Are you simplifying each of them? Are you converting to mixed numbers? Are you comparing to half? Whatever you're doing, okay? I need to see the work there. Then we kind of do a wholesale review at the bottom. I don't want to erase this. I want to keep it up. I'll scooch. Oh, I don't need to scooch down. Right there. Perfect. First one, all fractions, ordering from least to greatest. What can you tell me about those 4 fractions? Again, don't give me any answers here, but just look at those values. How can you make this a little bit easier of a process based on the values that you have there? Abe, what do you see?
Like the 3 and 3 are even denominators.
Okay, you've got 2 of them with like denominators already. That can be helpful. What else can be helpful? Aiden? Okay. Well, I see 2 of these are proper fractions. I see 2 of them are improper fractions. Proper fractions, by definition, are less than 1 whole. Improper fractions are greater than 1 whole. So you know that the proper fractions have to come first. The improper fractions have to go second. That can be helpful. Break down a little bit. Okay. The next one is all decimals. And the last one is a mixture of decimals and fractions. Good thing we've already talked about how to convert from decimals to fractions to decimals. You could use that knowledge from CO2, I believe, to your advantage here. So, 15 minutes now to work. The rest of PO7, anything you may not have finished, but you all did, so I guess that's a moving point. The rest of PO7 due tomorrow, and I think tomorrow we're going to go over the math packet. So bring your math packet with you tomorrow. It's due next Tuesday, but if you got questions on it, we'll cover those tomorrow. Yeah, Ethan.
Have you graded mine yet?
If you turn them in early, I don't grade them until the weekend before they're due. So no.
When are they due again?
They're due next Tuesday. Next Tuesday. Ziggy. Summary sheets are due tomorrow. If you have it signed today, then I will check that in. So I'll come around to that after we're done recording. Otherwise, they do need to be done. Signed tomorrow. Yes.
I got my test back.
Correct. I've got it up here. James is saying. All
All
right, folks. That's how you math.
Don't forget to like.